Hello, this is Maria from Math Mammoth, and this is Mathy, my mascot. In this lesson, we are continuing to study how to use scientific notation in calculations. And you see on the screen two calculations. One is addition and one is multiplication. Let's look at the difference between the two and how we handle them. The first one is an addition. And to add these two numbers that are in scientific notation, I want to write them both with the same power of 10. So I could either change this 10 to the 8th to be 10 to the 9th, or this one to be 10 to the 8th. Okay? I'm gonna do the former. So I will keep this. You can do it either way though. And then over here, if I make this to be 10 to the 9th, it becomes 10 times what it is now. So then this has to be divided by 10 here and becomes 0.8. And now I can add these multiplicants or these coefficients here, 3 and 0.8, to get 3.8 times 10 to the 9th. And now this is already in correct scientific notation, so we don't need to do anything else. Now let's look at the other, where we multiply. And that's actually maybe even easier, because multiplication can be done in any order. So I can do 3 times 8, 24, and then 10 to the 9th times 10 to the 8th. We add the exponents, right? Because it's 10 multiplied by itself this many times, and 10 multiplied by itself 8 times, so we get 10 to the 17th. But this is not in the proper scientific notation. 24 needs to become 2.4. Okay? So I actually, to go from here to here, I divide it by 10. So this exponent increases by 1. Let's look at one more addition problem where we have negative exponents. And we need to do the same. We need to either change this to be 10 to the power negative 6 or this to be 10 to the power negative 5. So let's say that I keep this as it is and then change this, okay? So 10 to the power negative 5, if I change this to be 10 to the power negative 6, then as if I gain a 10 times, so this becomes 10 times what it is now, 20. And now we get 25 times 10 to the power negative 6. And lastly, in proper scientific notation, this I need to divide by 10. This one gains a 10, so it becomes 10 to the power negative 5. Okay? I hope you followed me. Now let's look at diameters of some heavenly bodies here. We have Jupiter's, Earth's, and Sun's diameter given in scientific notation and in miles. And now if we look at these two questions here, how much bigger is the Sun's diameter than Jupiter's? In other words, what's the difference between them? And then how many times bigger is the Sun's diameter than Jupiter's? The second one is a multiplicative comparison, and that is more common when we are looking at scientific data and big numbers. The first one intends to be just a simple subtraction problem. We look at the difference between the two numbers. Let's now solve both. Okay, now let's look at the first one, the difference between Sun's and Jupiter's diameters. And so I have written here, if we subtract the two, so 8.65 times 10 to the 5th, and then minus 8.88 times 10 to the 4th. If you look at these two numbers, you can already see that they are not the same. They differ by a factor of 10 approximately, because both of them, 8.65 and 8.88, are close to each other. But then we have 10 to the 5th, 10 to the 4th. So there's a 10-fold difference in size approximately. To calculate, when we're adding or subtracting, we want to have the same power of 10. So let me change this one now here to be 10 to the 4th. So this one will be 1 power of 10 less, 10 times less. So then this gains a 10, or 10 times, I should say. So it becomes 86.5. And now we can subtract 86.5 minus 8.88. And it is 77.62. And now we have 10 to the 4th here. And then what else? We need to continue because this is not in the proper scientific notation. Plus we need to check the rounding. In proper scientific notation, we get 7.762. times 10 to the 5th miles. And now to round, when we are looking at addition and subtraction, we are not looking at significant digits, but instead we look at the number of decimal digits and choose the least accurate and go with that. So the number of decimal digits, we have to have them in the same unit here, 10 to the 4th miles. So 86.5 is to the 10th here, 1 decimal digit, and here we have 2. So this one here should be just 77.6 to that accuracy. So we will drop the 2 from this last one and give it a 7.76 times 10 to the 5th miles. Okay, and now let's look at that multiplicative comparison. How many times bigger is the Sun's diameter than Jupiter's? And here we have at the top Sun's diameter, and then at the bottom the smaller number, which was Jupiter's diameter. And we divide to find how many times the Sun's diameter is Jupiter's diameter. And I have already done the calculation as far as from the calculator, taking this divided by this. Okay, so that's this long decimal number. Now we will also do the powers of 10, divided them, which leaves us just 10. Okay, 5 minus 4 leaves just 10, or 10 to the 1st power. The miles then cancel out. Here we need to round according to the significant digits. There was 3 and 3, so leaving 3 here, 9 and 7 and 4. But it is times 10, so that leaves it as 9.74. So that's the answer. Just a simple number seems like, but basically the Sun's diameter is close to 10 times the diameter of Jupiter, as our calculation shows. So, it was a simple answer this time. Okay, I hope this was helpful.